Okay, here's video number 3. So we look at this. The residual plots of 5 different least squares regression lines are shown. Which of the plots provides the strongest evidence that the regression line is appropriate and is consistent with the assumption required for inference for regression? In other words, which of these give the best linear model? Okay, there's a curve. That answer is no. There's definite curve. That answer is no. So it's one of these 3. If we look at this one, I'm going to just start down here. It's narrow and then it widens out like a cornucopia or something. Where on this one starts wide and narrows. But then we have this one which is scattered all over the blank in place. So obviously the best answer on number 21 is C. Okay, number 22. Okay, a random sample of 50 students at a large high school resulted in a 95% confidence interval for the mean number of hours of sleep per day. Okay, so we are 95% confident that the true mean value for the number of hours of sleep per day for this high school falls somewhere between 6.7 and 7.67 hours per day. Okay, what does that mean in context? Well, that means that if I were to do a bunch more samples of 50, that I would expect about 95% of them to contain the true mean. I would expect about 95% of them to contain the true mean. Okay, about 95% from the popular result in a 95% confidence interval of this? No. I wouldn't expect them to have the same interval. Okay, about 95% of the population will result in a 95% confidence interval that covered the population mean number of hours of sleep per day. Ding, 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 ding. There's my answer. Okay, now let's go ahead and look at this. 95% of the students in the survey reported no. 95% of the students in this high school sleep between no. Selected random the population per day for 95% of the time? No. Anytime it just talks about straight percentage of something occurring, that's not it. We would expect about 95% of the samples of size 50 to have the true mean of the population. Okay, so here we go on 23. Local company is interested in supporting environmentally friendly initiatives such as carpooling among the employees. The company surveyed all 200 employees who at the downtown offices. Employees responded as they'd rather not own a car in the location where they live. The results are shown in this table. Categorical data, ladies and guys, categorical data. Could do a chi-squared for this, but it doesn't ask us to. Which of the following statements of the randomly chosen person for these 200 employees is true? Okay, if a person owns a car, he or she is more likely to live elsewhere in the city than to live downtown. Okay, ding, this is already my answer. 10 live in the downtown, 15 live elsewhere in the city. So if the person owns a car, we expect this number to be bigger than that number. That's true. That's my answer. Okay, but we'll go ahead and look at this. If the person does not own a car, he or she is more likely to live outside the city than to live in the city. Doesn't own a car, does own a car, does own a car. Okay, these two numbers are much bigger than this, and they would think that they would live outside the city. Okay, the person is more likely to own a car if he or she lives in the city than if they live outside. No, more people outside the city own a car than those who don't. And then the other two don't make any sense either. I'm just not going to spend the time to go over them. Okay, number 24. Random sample of 432 voters revealed that 100 are in favor of a certain bond issue. Okay, so first thing I do is I go 100 divided by 432 equals 0.231. This is my p hat, which makes q hat 0.769. Those are important to us. We're doing a confidence interval for the bond issue is, okay, so our mean value here, what we're expecting is going to look like this, p hat plus or minus z star square root of p hat q hat over n. Okay, this is how we find it. Well, so p hat is 0.231. So nope, 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 right? It is a 95% confidence interval, 95%, Z star is 1.96. D is my answer. We had to find the P and the Q and see that those all fit in there. See, there's P hat, Q hat, and my N. Okay, 25. Okay, commuting time traveling from is normally distributed. Oh, normal distribution, normal distribution. 30 minutes. Standard deviation of 5 minutes. Student leaves at 8:25. What's the probability will arrive campus later than 9 a.m.? Okay, later than 9 a.m. means they were traveled 30. It took them 35 minutes. Okay, so we want later or we want greater than 35 minutes. So that is this area. Greater than 35. Well, I want you to think. Right here is 50. This is 50% of all the data, right? This is 50%. Well, this is 34. 50 plus 34 make, correct, 84. If I subtract 100% minus 84%, I get 16%. So this is 16% of my data, or question answer A, 0.16. Okay, the next question, a survey of student usage found that 79% of adults ages 18 and older in the U.S. use the internet. A broadband company believes that the percent is greater now than it was in 2009 and will conduct a survey. The company plans to construct a 98% confidence interval to estimate it. Okay, so we're looking at a 98% confidence interval. And if we look on our table real quick, 98% confidence interval is going to be a 2.326. Okay, now look at my answers. There's no 2.326, but there's 2.33. So these two are not my answer. This is 2.33. It's going to be one of these three. All right, I'll go back to the problem. Margin of error is 0.025. So no more than 0.025, 0.025, 0.233. There's my answer right there. The answer is D. I didn't have to do anything else. Okay, number 27. A manufacturer claims its brand A battery lasts longer than its competitor's brand B battery. 9 batteries of each were selected independently, and their tables are selected or shown below the battery life. Provided the assumptions are met, which of the following tests should be conducted to determine if brand A batteries do, in fact, last longer than brand B batteries? These are numbers. This is not categorical. This is an hour. These are manipulated. These are means. We could find the means of these lists, okay? Which means is a t-test. There's 2 pair, and we're trying to determine if one lasts longer. So we're saying that A is greater than B. Not that there's a difference, but that it's greater than. So that is a one-sided 2-sample t-test. Okay, so question 28. They conducted a 2-tailed hypothesis test and got a p-value of 0.44, which means this. If I have a normal model, means I found a percent over here of 0.22. This is 2-tailed, and a point over here of 0.22. So if the experimenter conducted a 1-tailed with the same data, which would be true about the possible p-values the experimenter could have obtained. Okay, if this is 2,2, so this is gone, then what is the value from here to here? In other words, what's the complement of this? That answer is 0.78. So the possible p-values are either going to be 0.22 or 0.78. Okay, hope that makes sense to you. Number 29. Okay, 29, we're going to have to run a test. A randomized experiment was performed with 2 fertilizers with different yields. Total of 33 tomato plants, 16 using A, 17 using B. Doesn't matter, they're not the same. The data did not show marked skewness, and there were outliers. The results are shown below. Okay, mean, standard deviations, and ends. So Which of the following best describes the conclusion to be drawn from this experiment? Alrighty, we're given numbers, so let's plug them into the calculator. Stat, we're going to do a test. There are two samples. These are means, so it's going to be number 4 there, a two-sample t-test. And I plug the numbers in. I go stats. There's my mean of the first data set, its standard deviation, and the number. There's my next one, 2.39. There's my standard deviation, and my n. It says, are they different? Gives different yields. They're not the same. If they're not the same, then it's not equal to. We don't pull it, we calculate it, and there's our p-value, 0.016, 0.016. So we look at the intervals that they give us and see where a p-value of 0.016 would fall. That's greater than 1%, but less than 5%. And that answer is here. See, this is not this, that's 15%. Remember, our p-value was 0.016. So it's greater than 1%, but less than 5%. And that is answer D. Okay? It's greater than 1 and less than 5. So the answer on that one is D. Okay, number 30. Which of the following procedures would be most appropriate to use for investigating whether there is a relationship between vehicle type and color? Categorical data. Categorical data. Categorical data is some type of correct chi-squared. Now, is it a goodness of fit or is it a test of independence? We're trying to see if this is related to this, if there's an association. So that answer is E. Okay, the other way of thinking of that, goodness of fit is going to be one row of data, just a singular row. This has two rows of data, two different categories with 5 different color categories. So this is a chi-square test for independence. Hope that helps.